So without too much further ado, we're going to have Kevin and Reshma talk about adding SoftNIC capability to DPDK. Thank you.
So, hi everyone, my name is Kevin. This is Reshma. We're both network software engineers from Untitled Chapter in Ireland, and we'll be presenting on how to enrich your NIC's capabilities with DPDK SoftNIC today. So, I'll give a quick overview of what we'll go through. So I'll go through this, why you should use SoftNIC. I'll give a quick overview of what SoftNIC is and how it works. And then Reshma will go into some more internal details of it, give you some use cases, and that's pretty much it for this slot. So why should we use SoftNIC? Well, if we think of it in terms of what we have in DPDK, we notice that we have a lot of ETHDEV APIs, we have a lot of NIC vendors, and there's lots of differences in the features that are supported by those NICs. So with that, we face inconsistencies in the development environment. It's difficult for applications to accommodate for all of the NICs, and it just makes it even harder to write the applications and maintain them. So that's where SoftNIC comes to the rescue. SoftNIC provides us with a software fallback for physical NICs by augmenting the features that are missing. This is brilliant for the applications because now we have a sort of layer between the physical NIC and the application that makes all NICs look the same to the application. So the development environment is suddenly consistent to the application and doesn't care about what actual hardware is underneath. Some other benefits that come with it are usability. So it's easy to use advanced features in DPDK by using SoftNIC without redesigning your application. And some consumer applications also get some performance improvements, but that's completely dependent on what you're actually running. So a quick overview of SoftNIC. It's a DPDK pole mode driver. That means it's easy to use with any application. All you have to do is add the --vdev option in the CLI for your application, and that'll spin up a virtual device, being your SoftNIC, and you pass what we call firmware script. So it's just a configuration script as a parameter with that --vdev option. Inside the firmware script, you can enable and disable whatever features you want to have that are missing, and that firmware script is a nice sort of abstraction and reduces the complexity of configuring the internals that DPDK runs on. So just a general overview of how a packet would go through SoftNIC. So if we look at what components we have first, in the orange on the far left and far right, we have physical NICs. Then attached to those we have hardware queues. The green in the middle is our application, and the bigger blue boxes either side are our SoftNIC RX and TX. Between the hardware queues and the application, we can have multiple pipelines to augment the features. So you could have whatever features you want. You could have routing, flow classification, anything like that. You can have any number of them either side, chain them together to make things as complex or easy as you like. And each SoftNIC component has three main parts, being tables, actions, and ports. So if we follow a packet's life through your hardware NICs, your SoftNIC, and the application, your packet will come in on the NIC. It'll get assigned to a hardware queue, and that hardware queue is matched to a table. So that table will pull the packet from the hardware queue. Then we have a bunch of rules inside that table, and those rules check the packet. If a packet matches that rule, an action is applied to the rule. That rule then decides where the packet's going to go next. So this can be either to another table or to an outbound port, which in this case is a software queue. So let's just take the easier option. It's going to go through to a software queue. Then it's ready for the application. So the application can pick the packet from the software queue, do whatever packet processing it has to do, and then it puts it onto our TX software queue, and it's ready for SoftNIC to take it back and do all the TX stuff that it likes to do. So then the TX side is practically the opposite of the RX. So the SoftNIC takes the packet off the software queue, goes to a table, checks for rules, matches a rule, applies the action, then that goes through multiple tables, potentially, gets put back onto a hardware queue, and then from the hardware queue, out the port back onto the wire, out to wherever you're sending it. So I hope that made some sense. I'll pass you over to Reshma now for some more deeper internals.
Yeah. So far, now we have learned that SoftNIC provides a software fallback for the missing features of the hardware. So let's see how this can be achieved internally. So for this, to achieve enormous features, SoftNIC needs some configuration script. It's supposed to have a configuration script where applications can go and configure or define the script such a way that what features they would like to have that are missing in the hardware. So the script on the right side of the slide is a default example script which can be used as a reference to configure a complex scripts further. So internally, who creates this SoftNIC and who has to do the configuration? All these details are something like this. So the application threads the service cores has to do this job. So service cores are something dedicated L cores which will be doing service related work items for the missing features of the hardware. These service cores are facilitated by the EAL in a DPDK. So other than the service cores, application threads also can do by themselves if they would like to do this configuration and creation of the SoftNIC. So first, these threads, what they have to do is they have to create a SoftNIC device as a virtual device in DPDK. To the creation, they need to pass this firmware script as an input. Then after creating a SoftNIC device, they have to take care of creating a number of receive queues of the SoftNIC and transmit queues of the SoftNIC. That defines the length of those queues. And then after the queue creation, it will be the next step would be starting the SoftNIC, the created SoftNIC device. And the start is the step where the actual magic starts, where it loads the firmware script that application had defined to do certain job. So at this stage, I would like to go through the firmware script details. So it does take care of, as a first step, it will create it will detect the links that are available on the board, and then the next step would be creating a pipelines, and then followed by creating the input and output ports that should be for the pipeline, and then followed by associating those input and output ports to the pipeline, and creating a set of tables that the pipeline should be handling. And then the created table should be again mapped to the pipelines. Then it will be, once the firmware, the next step would be like application threads, they can upload these tables with a certain set of rules. Rules will be actions that are going to be applied on the packets. To do that, they can call existing flow, QoS and security APIs that are available in the DPDK. Once that is done, these threads has to take care of running a SoftNIC run API in order to run the pipelines actually, which will be doing the handling the packets, receive, transmit, and operating or applying the rules that are configured in the pipeline tables. So next slide will be on use cases. Let's start with the basic use cases which we can achieve with the SoftNIC. basic use cases could be switching and routing, and some flow classification related use cases would be firewall, encapsulations like a GRE, yeah, and then NAT related applications also can be achieved. And traffic management related like QoS, policing and metering also can be done with this SoftNIC. And it does support, to achieve all this, SoftNIC internally uses the optimized DPDK libraries like Liberty, Port, Table and the TM and metering APIs. So apart from these basic use cases, there can be complex use cases like BNG and DRAS, and we can implement complex pipelines, uplink and downlink pipelines of this BNG and DRAS. If we take the first picture, let's say the physical NIC has we have certain color markings there. The orange will be available features that are available in the physical NIC, and the gray would be missing features that are not there in the physical NIC, and the green will be application. So with SoftNIC, what you can do is whatever is missing, you can implement using SoftNIC, and you can load them on a particular host where you would like to run them and be in the middle of them. So that's how you can achieve the missing features with the SoftNIC. So with this, I'd like to pass to Kevin to take further.
Okay, so just to wrap it up, 4 main key takeaways. SoftNIC provides a software fallback for NICs, so whatever your NIC can't do, SoftNIC can fill in. We can consume complex DPDK features without application redesign, so you can just call that with SoftNIC. You potentially get a performance improvement for consumer applications, which I don't think anyone would complain about. And the many use cases we have go from simple forwarding to as complex as you want to make it. The most complex ones we've had there are BRAS and BNG, but the possibilities are really endless. We have some documentation here. It's just on dpdk.org. It's for SoftNIC. So if anyone wants to play around with it, go have a look at that. It should help. And that's pretty much it. I'd like to say thank you. And if you want to get in touch with any one of us, feel free to do that if you have questions. We probably don't have much time for questions, but if anyone has some, fire away.
Yeah, with the tables, when the NIC's instantiated, can you dynamically manipulate the table or inject new tables?
You can. So there's a telnet client, and you can just call that up and just put in things. Yeah.
Apart from there, yeah.
Two questions actually. How many CPU do you need per port, or how many ports can be supported per CPU? And also, for when you have a CPU which is managing several ports, several physical ports, can there be different kind of NIC in terms of missing features?
Okay, we need we can create a pipelines, and one pipeline can be mapped to single CPU core, or multiple also can be mapped.
Specifically, do you say that if I ask for a missing offloading, like, I don't know, Geneva VXLAN offloading, you can implement it in software if my NIC don't implement it, like it's not Mellanox or something like that, my more general purpose. You do it in the...
Yeah.
Correct. Yeah.
DPDK Flow, yeah. DPDK Flow API, DPDK Flow API does provide this kind of encapsulation. It does has a VXLAN encapsulation process. So SoftNIC uses them as of now, and it has a support for doing a VXLAN encapsulation on the packets.
And you can indicate if the cost in terms of cycles with CPU, it's possible to measure, because if it's not offloaded in hardware but it's doing in software, even if optimized, you have a cost to pay for it, no?
Yeah.
If you offload. But do you have some benchmark that demonstrates how much is different than having a real offload?
No.
So very quickly, I don't think we've benchmarked that. But what you can do is you can make a pipeline that does that VXLAN offload, pin that to one core, and then just see what that core is doing specifically, and then you could have your numbers, yeah. Happy to talk to you afterwards if you have questions, but we're out of time. Thanks, everyone.
Kevin and Reshma?